Guys, welcome back to my YouTube channel. Today we'll deal with fluid mechanics N5 is being and why not posting. We'll deal with compressibility. I want us to deal with this topic right now. This problem, we are given 2.2. These things reads as follows. Say a cylinder with a diameter. They've given us a diameter there. 60 millimeter is filled with hydraulic fluid with an isothermal bulk. Here you see this, it has an isothermal bulk, right? Has isothermal bulk, and fluid is isothermal bulk of, they've given us this is the isothermal bulk of 2,035 gigapascal. The length of the cylinder filled with fluid, this is the length of the cylinder. This is the total, that is the length of the cylinder, which is this. What is going on here? Length of the cylinder there, 170 millimeter, and the effective Young modulus of elasticity of the material is that is 8,8 gigapascal. When a force applied to the piston, here we've given is 3.4 kilonewton is applied to the top. Here is applied to the piston, must be applied to the bottom piston, but is applied to the piston there, or is applied the force. Okay, right, no problem there. Then 2.2.1, the question says determines the following. 2.2.1, the cylinder stroke volume in cubic meter. Oh, fine, that is the volume, right? Okay, no problem. Then again, the pressure, 2.2.2, the pressure exerted due to the force applied to the piston. Yeah, it's what I see, it must be applied to the piston. Yeah, but must be top of the piston either way. And then 2.2.3, the bulk modulus of bulk modulus of air in megapascal if Y is 1.4. Okay, right. The effective bulk modulus in megapascal if there is 3.44 air present in the system. Okay, there is air here. The play, which is the play, is the change in length. If you used to watch my videos, you know when they are talking about play, you know we're talking about the change in length. It's just a fancy words. This is the same. Play is equal to the change in length. It's the same words. In other words, here they say determine the change in length on the piston due to the presence of air in the cylinder, because play is the same as the change in length. Okay, fine, no problem. So yeah, this is the questions. Okay, let us solve 2.2.1, the cylinder stroke volume. Okay, the one volume, we know that volume, I hope that you know volume is area multiply what by the stroke length, right? This is just the basic stuff there. 2.2.1, the volume is 2. Only this was written by 2.0 is 2.2s. Look, I write 1 point something now. This is 2.2s, right? 2.2.1, right? The one, the volume. Okay, this is V, must be equal to the area multiplied by stroke length. We know that. This is pi over 4 multiplied by D, must be squared, right? Multiplied by stroke length. So this is how we will calculate that. Then let us put our stuff. This will be equal to pi right over 4. Let's check the diameter there. Let's check the diameter. This is our diameter is 60, which then you divide by 1000, then you'll get 0.06. Divide this by 1000, then this will be 0.06. Right, this is 6 here. Square that, multiply by the stroke length. What is the stroke length? They've told us the length of the fluid with 170 divided by 1000 will get 0.1. We'll divide 170 divided by 1000, so that will be in meters, then will be 0.17. Right, then this will be 0.17. Right, then you punch all of these on your calculator. Punch this on the calculator. Then what we'll get when you punch this? Okay, the answer that you got there will be equal to 480, right, 664, right, times 10 minus 3. This must be in cubic, right? Cubic meter. This is a volume. Cubic meter. This is the volume, must be in cubic meter, right? It's SI units 480, 66, 4, like this, times 10 minus 3. This is in cubic meter. Then this is your volume. You get that 2 marks there. If it was given, you will get that marks. Right, with your 2 marks there. 2.2.2, the pressure exerted due to the force applied to the piston. Right, the force that is applied to the piston. Okay, like due to the force. Which force? Now you must ask yourself. They say the force applied to the piston. Do they give us? They've given us force. Yes. Here they said when a force of 3.4, here is a force here. You see, force of 3.4 kilonewton is applied to the piston. Then we know that we want the pressure. Pressure is for, we know that pressure is equal to force divided by area. We have there, let us do our thing there. It's 2.2.2, right? Now we have here 2.2.2, right? Right, the one pressure is equal to the force applied on the piston divided by area. This is the formula. This will be equal to, we know this is 3.4 times, right? Must be 3.4, isn't it? 3.4 times 10 to the power of 3. Remember, it's in kilonewton. Because here you'll divide this, this would be pi over, okay, let me multiply by this 4 of the, remember here there will be 4. There will be 4. I want to multiply by this 4 on the top here. Then I'll left with pi times diameter squared. I took that 4 on the top, then I know our diameter there. What is our diameter? It was 0.06, right? 0.06. I square that stuff there, isn't it? Then punch this on your calculator. 3.4 times 10 power 3 multiplied by 4 divided by pi times 0.06. Then you square that. Supposed to get that your pressure after you've done this stuff here. If you've punched this, you should get that your pressure. Whoa, we need a pressure, right? The pressure will be right 1.203 megapascal. This must be megapascal. All right, must be in pascal. Pressure is measured in pascal, isn't it? It's measured in pascal, but this is megapascal because this represents times 10 to the power of 6. So I chose to write this in scientific notation. You use the SI unit there, it's megapascal. Okay, it's fine. This is your 2 marks, right? You'll get that 2 marks there. 2.2.3, they want the bulk modulus of air. Okay, bulk of modulus of air in megapascal if y is equal to 1.4. This is 1 max. I hope you know that the bulk of modulus of air is kg. We call that kg. That is kg, isn't it? That is just kg. Let me write here once. You can say right 2.3, right? 0.3 here. You know kg must be equal to this multiplied by pressure. Will be given like this on your formula sheet. This is always 1.4, right? Is equal to 1.4. I mean, you see, this stuff is always 1.4. You must know this, right? So if that is 1.4, therefore kg will be, this is pressure, right? You've calculated to do 1.4 multiplied by that pressure that we got there, which is 1.203. What's in mega? What's it here? What's in megapascal? Right. So this will be in megapascal. I'll just punch this on your calculator. Right. Then you'll get that to be in megapascal. Kg will be megapascal, isn't it? If you punch that, you'll get 1.68. Let me double check. It's 1.68, 1.4 times 1,0203, right? This is 1.68. Round this to the 3 decimal places. Then I maintain that megapascal there. Then maintain that your SI unit here must be made megapascal. Isn't it? So this is your kg. Right, we are done with this kg then. Therefore, what do we need now to calculate Let me string. What do we need to calculate? We're done with this. That one marks. Now 2.2.4, the effective bulk modulus in megapascal if there is 3.44% air present in the cylinder. I hope, guys, if you don't understand this, go check the playlist N5 fluid mechanics, right? Check that playlist there. You will find that they read the video that is written compressibility. There's one that I've solved the problem. I've explained what is effective bulk modulus and then effective bulk modulus. They said this is same as KE. Is KE this one? They said effective bulk is KE. Will be given by KE there. We will have K, then have little e there. This will be effective. Then remember this is an effective. Then I said KL, remember, but KL, the one which have L, I said KL, this is an ISO. It's ISO. It's an isothermal bulk modulus. The difference, this is the effective, this is effect. That one of KL, it's an ISO. Right. So yeah, you must know this. We must know that stuff. They want KE here because it's an effective bulk, it's not an isothermal bulk, but it's an effective bulk modulus. This must be make okay. We have given air, and then I spoken about this thing of air again. I've explained on that video. But okay, let us solve this 2.2.4, the effective bulk. We have the formula sheet there. It's a formula sheet. Let me just show you this formula sheet here. If you want, this is the formula sheet that speaks about those things. Here is the formula sheet there. I want to show you. We have a formula sheet. You see this one. I want to show you. This is the formula sheet. You see it says 1 over KE. I show you this is E is equal to 1 over KL plus 1 over KC plus VG over VT into 1 over KG, right? I've told you that, and then you see that KG is this multiplied by P, and KC is equal to E over 2.5, right? So let me just break down this formula sheet okay. So the formula sheet there, you see this formula sheet. We'll use this formula sheet. We'll use that formula to calculate the effective will be given on the formula sheet. But see, what is important, you must know what is KE represent. Effective bulk, isothermal bulk will given KC is 1 KC. You must know the K. You must know KC. It has formula. You see, KC is here. Its formula, which KC is equal to E over 2.5 as always, unless if they stated otherwise. So you must know, and then you must know V G over VT. This will be called to the air percent, but you must write it in fraction. Let's say we are given 2%, right? But because this is in fraction, it must correspond with this, so that this change this to in fraction will be equal to what? When you change this to in fraction, that will be equal to what? Will be equal to 2 over 100. This is in fraction. So yeah, we'll replace this with this. So there will depend on what air that they've gave us, a percentage. This is an a percentage. Kg is this one. We've calculated it. You must understand your stuff, right? Okay, then, but go to my playlist, then you'll understand. I've explained these things. Now let us solve our problem here. You see, We have that kg there. Now we want to calculate the effective bulk modulus. We'll use this formula, right? We'll use this formula, right? So let me drag down. Cool. Let us solve our stuffs here. Okay, this is the formula. We know it's 1 over k. Here it's E, right? Formula will be equal to 1 over KL plus 1 over KC there, KC, then this will be plus VG over VT, right? This into 1 over kg. Must know this formula sheet. It's important. It's important for you to know this formula, right? Let us apply this formula. We substitute. We want E, but we have 1 over E. Okay, 1 E there. No, this is 1 over K E, then 1 over KL. You want KL, it's the isothermal bulk. Remember, KL is equal to isothermal bulk. Let's check, do we have isothermal bulk? Their length, if you read this, you'll see that they've said that filled with hydraulic fluid. They want a cylinder with a meter of 60 millimeters filled with hydraulic fluid with an isothermal here. Isothermal bulk modulus we have given is 2.035 gigapascal. That is equal, this is equal to KL always, right? Yeah. Alright, that is KL. Substitute your stuff there. 0 is 2.035, right? Gigapascal. Now you know this is 3 is is 2.00 watt. This is 2.035 okay, times 10 power 9. Remember that it's in gig, right? All over. This is 1. We are done with this part. Let's go to the second part. We would 1 over kc. This will be plus 1 over, what is kc? Kc we don't know, but we know that kc is equal to, I showed you on your formula sheet. Let's go again and show you. Here it's kc, here it's kc, right? Kc is equal to E over 2.5, right? That is kc. kc is equal to E over 3.25 2.5 or 2.5. This is the Young modulus of elasticity. If you did strength of material, you'll understand this. Or if you take strength of material, you'll understand what is elasticity. Let us check. Do we have elasticity in our question here? Young modulus. What is the Young modulus? Okay, they've told us that you see the Young modulus here. The Young modulus of elasticity of the cylinder is 8.8 gigapascal. It's 8.8 that one gigapascal. Right, it's 8.8 gigapascal. Then there, Kc can simply here and substitute. Can substitute here will be 8.8, right? Gigapascal. This will be in Pascal. Divide this, punch this. We'll have Kc will be 3.52 times 10 power. It's in power, it's in gigapascal or what? Let me check here. It's in megapascal or gigapascal. Yeah. Young modulus of elasticity. Yeah, it is in gigapascal. Oh, that is in gigapascal. Then we'll have 8.8 divided by 2.5, right? This will be 3.25, but must be in gigapascal. This will be 3.25 must be in gigapascal. So we'll substitute this here because it's Kc, right? Let us substitute that. What I'm doing here, sorry about this. Let me just erase this. Okay, this is over. We know that will be 3.52 times 10 power 9, right? Let me here, it's 1. We're done with this second part. Let us go to Vg over this will be plus Vg over Vt. This part here is Vg over Vt. Okay, now they say what? Vg over Vt. I've explained this. Also this here given on the formula sheet. You must know this. It's a air, represent air, right? The percentage air. This will be air. So let us check that we have given m. A, you say it is 3.44. Here it's m, 3.44%. So I've given that air is 3.44%. But now must be in fraction. This is in fraction. Also this, let us represent this in fraction. If you represent that in fraction, this will be equal to, you want that to be in fraction, will be 3.44. Remember, the percentage represent 100, represent divide by 100. We will substitute this there. So here we will substitute, here we'll substitute, there we'll substitute that. So yeah, so this will be 3.44 over 100 into 1 over kg. Here is kg, we have calculated it here. You see it's 1.6, 1.68 8.4 watt megapascal. Okay, times 10. Let me just do like this. Let me try and scroll here. Because there is no inner space, let me multiply. Okay, let me try and grab and take this thing. Right. 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 This is the same as over 1 is the same as, okay, let me try and do this, plus your plus 10 power. Okay, I want to multiply this times 10 to the power of, what is that, megapascal times 10 to the power of 9. So this is over 1. All right. When we punch this on the calculator, remember that one is 2. Here there is, don't remember there is 9 here. Right. There is 9 somewhere there. Here there is 9. Remember it's 1 over 2.035 times 10 to the power 9 plus punch all plus 1 over 3. This is 3.52 times 10 power 9 plus 344 over 100 into 1 over 1.684 times 10 to the power 9. Then you're supposed to get that K1 over KL over KE. So that is equal to, punch that on your calculator, we'll have 2.0 21.1 comma 203,044, that's times 10 to the minus 9, right? Then this, it's maths. I will take this on the top. Remember 1 KE, then this is the same as 1. I take the 1 on the top, then this will be KE, right? It will be KE like 1 over 21 comma 20344 times 10 to the minus 9, right? Divide this by that 1 there on the top. Here there is 1. Divide this by 1. If I punch this on the calculator, 1 over 1 divided by 1 divided by 2 by 21. What is wrong with me? I feel like I'm tired. Okay, 1 divided by 21 comma 203,044 times 10 to the minus 10, then you get KE. Our KE will be equal to, I can see I'm tired. This will be equal, when you punch that on your calculator, 47 comma 143. This is in megapascal, right? There it is. This is KE, effective bulk modulus. Yeah, you'll get those marks. That is an effective bulk modulus. You'll get that 3 marks. Last question, 2.2.5. The play on the piston due to presence of air in the cylinder. Play, I've explained this. Play. I've explained this. Play is the same as the change in length, right? This is equal to play. So what about that, guys? Which is the play, change in length is equal to the play. We're done with this. Let us calculate the play. Let us calculate the play. Let me we want the play. Okay, play, that is 2.2.5. We want the play, which is the change in length. Yeah, there are things that's supposed to know. The change in length, we'll use this formula. Change in length over original length must be equal to P over KE. It's important to know this formula. We take this formula. Also, you must know this can be equal to change in V over V. Actually, it's a strain. Remember, if you do the strength of material, strain is a change of something over its original, right? You must know that. So this is the change. This is the formula we'll use. This is equal to play. Change in length is a play. We want the play. We know our change in length is equal to the play. Then we multiply that side. That will be pressure. Will be P. Pressure multiplied by L over KE. Right. This is the change in length. We'll find when you substitute in this formula. We'll find the play. So our play actually, you see, we're checking this thing here from these two formulas. If you can check, if you can make, we're taking this in these formulas, we equate them. We made the subject of formula E. We have made the formula subject of the formula EV. If you make the subject of the formula to be the same throughout, you will see what will happen there. Now let us find the change in length. Now we know the formula that we're supposed to use, isn't it? We know now what the formula is supposed to use. Supposed to use this formula there. Here is our formula. Supposed to use this. So this will be equal to the pressure. We've calculated it. It's 1 point in the, we got, remember, we got 1.23 times 10 to the power of what, 6, multiplied by the length. The length of this thing we've given, where is the length, is 107. To divide that by 1000 will be 0.17, then 0.17, then you divide this by KE. Our KE is this. We got the KE here, it's KE. This is KE. You remember, this is our KE. We'll divide by that. It's 47,143 megapascal. Okay. 47,143 megapascal, which is same as times 10 to the power of 6. Right, this and this will cancel. Right, this and this will cancel because it's the same. Then we'll multiply, or just make your life easier, punch all of these in your calculator. Punch all of these in your calculator. Punch all of these in your calculator to make your life easy. Punch all of these on your calculator. You're supposed to get the change in length. Change in length is equal to 4 point, what is that, 4 point what, 4.336 millimeter. Remember, I got my answer as the number that, if you punch this, what you'll get on the calculator, multiply it by 1000, so that will be in millimeter. Will be in the number that you'll got will be in decimal. That you'll get, you multiply it by 1000, then you'll get this. Here it's our final answer. here it's a play. This is equal to play. This is the play. This change in length is the same as the play. Then we are done like that. Thank you guys for your time. Don't forget to subscribe to my YouTube channel and comment also and like. Thank you.